Hello, I am Alicia Herrero de Bon, Professor of the Department of Applied Mathematics of the UPV, and I am going to present you the Basic Mathematics course on linear algebra. In this course, we are going to deal with two essential parts of linear algebra, systems of linear equations and matrices. Both are fundamental work tools that appear in multiple areas such as geometry, physics, computer science, engineering, etc. In fact, you already know some of the applications of linear equation systems. If you want, for example, to find the intersection point of these two lines that you have on the screen, then if you know the equations of the line, you simply have to solve this system of linear equations. This system will give us the coordinates of that intersection point. These lines can represent anything. For example, the evolution of a product in the market, with which the intersection point interests us to know when to change the product or anything else, depending on the area in which we find ourselves. Also, for example, the linear equations, if I want to solve this circuit and find the intensities in each of the lines, I1, I2, and I3, in this case, applying the laws of Kirchhoff, this system of linear equations would give us where the 5 coordinates and 1 and 2 and 3 would know how to solve this system. Also, if we now focus on the matrices, this system, for example, also has a matrix expression. This matrix expression already makes the matrices intervene in the solution of the system, which would give us exactly the same solutions and 1 and 2 and 3 for the same circuit. This is another application of the matrices and another way to solve the electric circuit that you have on the screen. But the matrices not only appear as things associated with the linear equation systems, they also appear, for example, whenever we can build a number table. For example, here we would have this number table that also has this representation as diagram of Venn, where, for example, 1 to 2 and 3, B1, B2, B3, and B4 can represent 2 cities, 3 cities, and 4 cities on the other side, where each arrow, for example, can represent roads that join those cities. Of course, this study with the matrices could help us, for example, to improve the infrastructure between cities. Well, this is another application of the matrices. In any case, we are going to base on knowing the linear equation systems and the matrices and work with them mathematically in an appropriate way. So in this course, the first thing we are going to remember is how to solve algebraic equations with a single unknown, simply a little to remember the operations between numbers and how to display unknowns in an equation. And from there, we will move on to one of the main contents, which are the linear equation systems, where we will see that it is a system of linear equations and how to solve them using the Gauss method. Once we have seen this, we will move on to see the matrices and the determinants. We will see that it is a matrix, that we can perform operations between matrices and how determinants are calculated and how we can apply these determinants to solve linear equation systems, to calculate the inverse in matrices, to see the rank of a matrix, etc. And this is the content of the course. I hope you find it useful and thank you very much for your attention.